Hello, geometry. Welcome, welcome. We are here to cover 2.4. It is called Deductive Reasoning. We've been in exploring deductive reasoning in 2.2 and 2.3, but 2.4 is officially titled Deductive Reasoning. All right, so let's fill in some blanks here. Deductive reasoning is the foundation of geometry. It is reasoning that is based on facts. It's based on definitions, theorems, postulates, and it comes from Euclid. He's considered the father of geometry. We are studying Euclidean geometry right now. The official name of our course would be a Euclidean type geometry coming from Euclid. And he organized all the building blocks of what we're studying using these two pieces of logic. So two pieces of logic under the umbrella of deductive reasoning, not under the umbrella of inductive reasoning, which is patterns, but under deductive. The first one is the law of detachment. And it states that if a conditional statement is true, all right, so we have to be given a conditional statement that's true. So what do you need to be given to make a valid conclusion using the law of detachment? A true conditional. So whatever it may be, it needs to be true. So right here, you have to look at if P then Q and assume that it is true. All right, so that's the first thing that you must be given coming from this explanation here. All right, so anytime then, if the conditions for the hypothesis exist, so if P then Q, so if you're ever presented with P, and if it is exactly stated, then you can go ahead and conclude Q. All right, so if you have a true conditional and you're presented with the conditions again, the conditions of the hypothesis, then you can conclude that the conclusion will be true. All right, it has to be exactly stated. So you have to have a true conditional, and then you have to be given the exact same hypothesis. And then you can make your conclusion. So if the conditional statement is not true, then you can't make a conclusion. If the conditions of the hypothesis do not exist, you cannot make a conclusion. It has to be exactly. This is almost too easy that it becomes difficult for students. It just has to be very cut and dry so you can make your conclusion. So basically, if today is Monday, then tomorrow is Tuesday. Okay, that's true. So we've got our first bullet point here. And now here's our second statement. And they're telling us now that if I tell you that today is Monday, what can you conclude? So there's our P. If today is Monday was our P up here, tomorrow's Tuesday's our Q. That's certainly true. I'm given exactly, precisely the same P, so I can conclude that tomorrow is Tuesday. All right, so simple summary would be you're given a true conditional, you're given the exact hypothesis, therefore you can conclude the same conclusion. Okay, so let's look at these two examples and then we'll go on to the law of syllogism. So assume the given conditional is true, all right? Perfect. And determine whether you can apply the law of detachment to make a valid conclusion. If no conclusion is valid, write no conclusion. Check using symbols. All right, so here we go. If Joe goes to the football game, that's P, then he doesn't go to the movies. And that's Q. The paragraph up here told us that that's true, so true conditional is met. So now we're given another statement, and it said Joe went to the game. So there's a second P. Now, do these P's match perfectly? Joe went to the game, if Joe goes to the game. Joe went to the game, if Joe goes to the game. That matches. So we know for sure that we can conclude that Joe doesn't go to the movies. Okay, so we can use our symbols here. I'll basically do it up here because I don't have much room. I can, I've got this as true. We're given P, so we can say therefore Q. All right, so the second one, if Joe goes to the football game, then he doesn't go to the movies. That's the same, if P then Q, so this is true. And now my second statement says Joe doesn't go to the movies. All right, so what did they give us here? They gave us that this is Q. That is not the perfect setup for the law of detachment. The law of detachment says the given here has to be the exact hypothesis, and they just gave us the conclusion, so we say no conclusion. All right, so just because he didn't go to the movies, it doesn't mean he necessarily, went to the football game. He could have gone somewhere else. So no conclusion there because the setup wasn't perfect for the law of detachment. All right, the second, so that's the first one, the law of detachment. That's our first one. Our second one is the law of syllogism. All right, so the law of syllogism is our second one, and this is going to feel a lot like the transitive property, if you remember that. So the law of syllogism. Just trying to stay on here. This allows you to string together two or more conditionals and draw a conclusion. Basically what happens here is the conclusion of each conditional becomes the hypothesis of the next conditional. Okay, so that reads a little weird, so let's look over here. So basically, if I have P, if P then Q, and then a second statement where Q becomes the hypothesis, and let's say Q becomes, I don't know, R. You're able to skip over this Q as long as the conclusion becomes the hypothesis. It's almost as if you're canceling those out. So A equals B and B equals C, then A equals C. It feels a lot like the transitive property. And so we're going to just look through the Q's. I can conclude, therefore P, therefore I can conclude if P, then R. So the symbol summary here is you have to be given these conditionals, and this Q has to be the start of the next one, and then you're allowed to, I'm basically just writing the same thing down again, you're then able to jump over that Q and string together if P, then R. Alright, so Sam is taller than Tom, so Sam is taller than Tom basically. Tom is taller than Eunice, and so this is allowing me to skip over Tom, and we can conclude that Sam is taller than Eunice. You're just getting rid of that middle link. All right, so what do you need in order to make a valid conclusion? You need one true conditional, all right, and then you need, so these had to be true. I guess I should have put that right there. Those have to be true. And then you can guarantee that this will be true also. And then you need another true conditional where the conclusion of the first becomes the hypothesis this conclusion became this hypothesis. The conclusion of the first becomes the hypothesis of the second. All right, one true conditional where the conclusion of the first becomes the hypothesis of the second. And then you can apply and do your linking right here. All right, so rewrite the following conditionals using correct symbol notation. Then decide on the order to make a valid conclusion. Write your conclusion as a conditional statement. Okay, so we have William reading a magazine. There's one statement. Let's call that P. Then he's reading a magazine about computers. So we'll make that Q. So this is just, he's reading a magazine. This is that it's a magazine about computers. This is if he's just reading in general. So we'll call that R, reading in general. Then he is reading a magazine. Okay, so he is William. So if William is reading a magazine, he's reading a magazine about computers. William's just reading, he's reading a magazine. So right here, these two are the same. If William's reading a magazine, then William is reading a magazine. So there's your link right there. So you need the conclusion of the first one to become the hypothesis of the second. So since this is the match, this P and this P is the match, I need this to be my first statement, and I need this to be my second statement, because this conclusion is becoming the hypothesis. So if I write this in symbols, I'm going to be writing R to P, and then P to Q. And so I can link those, and we can state, therefore, R to Q. So if William is reading, okay, and we're jumping through that. If William is reading, then he is reading a magazine about computers. Okay, so almost done here. 13 is kind of crazy. If I get good grades, then I go to college. If I get a good job, then I make a good salary. If I stay home, then I study. If I go to college, then I get a good job. If it's raining, then I stay home. If I study, then I get good grades. Wow, that is a lot to process right there. But if you organize it with symbols, you're going to be able to make a conclusion here. So let's use our symbols. And if I get good grades, we'll call it grades. Then we go to college. And job, then we make a salary. I'm going to put money there. And then if I stay home, then I study. So S is for study. If I go to college, then I get a good job. So we're having some repeats here, which is good. And then if it's raining, I stay home. And then if I study, I get good grades. All right. So let's see some matches. There's going to be a link. There's going to be a link with the home. Job is going to be a link. Let's see. Steady is going to be a link. And college is going to be a link. All right, so all of those are the links. So the ones that aren't duplicated, this is going to allow me to know how to start. So I've got to start with this hypothesis and go here. So this is going to be my start, and this is going to be my end. So basically, you're going to be able to conclude here, if it is raining, then I make a good salary, which is kind of funny, kind of silly, but this is just more like a little puzzle. So you would start with R to H. So we got that one. If it's raining, then I stay home. Then you would jump to the one that starts with H. If I stay home, then I study. So we just use that one. And then we'll jump to the one that starts with study. If I study, I get good grades. Use that one. Then we'll go to our G one up here. If I get good grades, I go to college. And then we'll go to if the one that starts with college. If I go to college, then I get a good job. And then last one is starts with job. If I get good job, then I make a good salary. So all of these were able to cross out, and you were able to conclude, if it is raining, then I make a good salary. All right, so kind of silly but kind of fun. All right, so that's all for 2.4, and I will look forward to seeing you guys back in class. All right, have a good rest of your day.